We interrupted our new chapter for a test yesterday. We're back to the new chapter now. I already gave you the chapter 8 homework assignment. I have no intention of reducing that one because it wasn't that long. And plus, it's really, really fast and easy. Once we show we've met the conditions, the math part in this chapter, like the math part in chapter 7, it is just fast and easy. Okay. We have already started talking about last week, good Lord. We started talking about on Monday about confidence levels and confidence intervals. And we're continuing that today. We discussed what they were and how to phrase things with them. We just didn't discuss really how to calculate them. So today is the start of that. The good news is, tiny good news, is that this formula is at the top of your formula. This is on your formula sheet. So we were just using these two formulas for chapter 7. And then right above it is the confidence interval formula that will help with chapter 8. However, how helpful really is a bunch of words if you don't know what the words mean. So, there's a price for that. But if you had a moment, maybe the words would help. Okay, so what we've been calculating when we're doing proportions today, we're going to do, we'll have to finish up proportions tomorrow. But we keep talking about it's either going to be a means or proportions problem. We're going to start off with proportions world. We've been dealing with this formula for proportions to find the standard deviation. We would plug in P 1 minus P over N and take the square root of that. That's what was on this sheet. We've been using this formula for a while now. Well, today we're going to use this formula, but we're going to slightly change some things. So what if we didn't know the P, but we did know the P hat? Then it's okay if we use P hat 1 minus P hat over N. So, and that changes the name of it too. So that's my little notes to myself of words to say out loud. You know how to do the standard deviation. That's what that formula was. You had to do it yesterday on the test. However, if we don't know P, then we can do the exact same calculation with P hat. However, clearly we've got to change the name of it because it's not the same thing, because P and P hat aren't the same thing. So what we would call this new thing is standard error. That's why I put SE, standard error. So if you have to use P hat instead of P, it's called standard error. Okay, and then there are some words on the page underneath that explain it further. When the standard deviation of a statistic is estimated from data, the result is called the standard error of the statistic. And the whole point of it is it describes how close the sample mean / proportion will be to the population portion mean in the repeated simple random samples of this size. So if we calculate our standard error, we still would say the same sentence like we were saying in chapter 7 about something about it would happen with all if our samples are always size 10. The way Kenzie was helping us word our sentences the other day, we would continue to word it that way. Okay, yes, dear. I don't care. Now, very rarely does anyone make you distinguish, am I dealing with standard deviation or am I dealing with standard error? So literally, again, you have this formula all the time. If you have P, use P. If you don't have a P, use P hat. They're not going to make you say this one is for sure standard deviation and the ones with P hats for sure is standard error. They don't make you specify because most people seem to get that confused. So that's the good news. So you have this. It's just maybe we might need to do P hats instead of P's because we might not know about our population, but we do know the probabilities with the proportions with our samples. Lord Jesus. Okay. The fun part today. Yes. No. Okay, so today we're starting to actually, we talked about confidence intervals. We talked about how we want a range of values. Like we're 90% confident it's between 10 and 20, or we're 85% confident and we want a range. That's what we were talking about. So today is how to get that range. Do you remember that? Let me show you and remind you of that. We discussed that Monday. Like, we want to say sentences about being some percentage confident and then give an interval. So today we're going to talk about how to get that interval. They're going to tell us the percentage we want, and we're going to talk about how to get that interval. Okay. So to get to this interval, obviously there's going to have to be a formula. And the first thing we need to know about that formula is a part of it is called Z star. So I've already actually boxed in the formula. If you want to box in the formula, you can. I'm going to put memorize next to it. Again, it in words is at the top of your formula sheet. So if you're looking at your formula sheet, this and this are the same thing. But just because Kenzie sees words doesn't mean she's gonna, I don't know how you are with words. So maybe, yes, the words are on the formula sheet, but the actual formula, not so much. So I would say memorize it. Which is gonna break Hunter's heart, because even my calculator people need to memorize the formula. If you just show the buttons you press and the intervals you use, if you're not 100% correct, they're not gonna give you even that P. So to at least get the P, you've got to show a formula. Okay.
Just write the formula down and put normal CDF.
It's not going to be a normal CDF thing, but yes, we're going to get to what button it is, and you can just put we'll talk about the minimum you need to have in order to still calculate everything, of course. Okay, so no. Getting closer, but no. Okay, so, we kept talking about on Monday, the part that you don't like, which is we don't get to do any math whatsoever until we've shown some things. We talked about it needed to be, what are the 3 things we need to check before we try to do any math with confidence intervals? Yes, dear. Yeah. Tell me the other things again, Kenzie. Yes. Well, but that only works with what? That only works with the n greater than 30 is what she's talking about, but that only works with means, and we're only doing proportions today, so that's not going to help us. She is correct, though. We've still got to do this, the normal of, can we decide that one was the normal? Yeah, the NP greater than or equal to 10, or the N 1 minus P greater than or equal to 10. Again, we probably don't know P today, so we might be doing P hat, but we're still going to check something. And then we talked about independent being the 10% thing, where at least my population is 10% larger. I mean, good Lord. My sample is only 10% of my entire population. And then random, we're praying they say that somewhere in the problem itself. But we're still going to check conditions before we get to do any math. The math's going to be pretty easy if we know our formula, but we've got to check these conditions first. Okay, hence the sentence in our first example. So they want us to figure out the Z part of this formula, and we actually call that Z star, hence the little asterisk next to it. Literally, the asterisk is intentional.
I did look at the bottom at first.
And they specifically tell us, assume the normal condition is met, because you and I are going to look at a normal table to try to figure this out. So we have to have this normality in order to use the normal Z table. So Z star is going to help us. We're calling it Z star specifically to deal with confidence intervals, but we're still going to use our Z table to help us figure it out. I'm going to use my Z table. You can. We'll talk about the calculator command in just a second, but you are going to help me with my Z table first. Okay, so we're wanting to know something called a critical value. So if you have out your formula packet, which I pray to goodness you do, and why you didn't have it out yesterday during the test, I don't know. You're silly. Okay, I hope so. You need to pull it out now because we're about to use it and it's going to be useful. Woo!
It smells fresh.
Thank you. It's my humidifier thingy still. Okay, so specifically we're told 80% confidence interval. So I know I want to have like 80% confidence. So what would the 2 tails be, not inside that 80%? Yeah. Okay, so then let's go back over, just humor me, because, you know, sometimes I just do math by myself and question my own sanity. We have two tables that say table A. One says this table this way with like negative stuff. We have another table A that has the positive stuff. And normally you and I, like, we look at, like, if we want to know 1.56, we go to 1.56, and then we get a percentage. But today we're wanting to do it backwards. They're telling us the percentage. They told us the two tails are 10%. So I literally want to know 0.1. Because you know percentages. So I know the middle is 0.8. I'm literally wanting to know down here. So if I'm looking at my table, I'm looking for as close to 0.1 as possible without going over. Okay. Okay, so you're looking at your table. You want as close to 0.1 as possible without going over. And then I need you to look out at the ends and tell me what Z numbers those are, because that's our Z star. So 0.985, where did you find that at, ma'am? 0.29985. I see that one, and then I see the 0.003. So I agree with her. Like, again, I like to go a little lower. It might be smart to take the average of the two. So Kenzie and I were thinking it was going to be this. And if we look overall, that's at negative 1.2 on this line, 0.9 on that line. So we were going to say our Z star was negative 1.29. But it might be better to take the average of those. So negative 1.285. And then, of course, you know, I am a table person, so I like doing this. But is there a button to do on the calculator that would make us even more confident? Yes. So could you do, you're going to get most of your credit, like unless you just mess something up after this. If you do Z star as negative 1.28 or Z star as negative 1.29, again, because you're not sure, should I go with this one that's a little over or this one that's a little under? I'm more of an under person, just saying, but anyway, that's just my thoughts. However, I realize that's not sufficient for those of us who are like, oh my God, no, I need to know the exact answer. So again, we were told we want 80% confidence. I drew me my standard normal curve. I realize 80% is in the middle. My two tails are 10%. You know, normally we're told this number, and I'm figuring out the percentages. Today, I'm told the percentage. I need to figure out this number, and we got negative 1.29 or 28 or whatever it is you think it is. Now, could we be more confident? Again, our table is static. I get that there's this like question mark of what should I put. Could we be more confident and use our calculator to get a more exact value and to make sure like which one is the real Z star? Absolutely. So we need to go to our calculator, and if you'll press second bars, well, yeah, but it told you that. It says inverse norm. Yeah, because we're doing the inverse of the normal curve. You know, for once, instead of wanting to know the percentage, we want to know the number that led to that percentage. So second bars, down to inverse normal. The only thing that's weird is area. So again, area is going to be whatever my confidence level was, or confidence interval. So I'm going to do 0.8. Oh, and that's wrong. Miss Common needs to think. It's 0.1. Duh. Back to it's the two tails.
So it's the area of the thing that we want.
Yes.
It's the area of the thing that we know.
Yes. But we still leave that the mean is, we still leave all the things. And we get negative 1.28. So Z star is negative 1.2815 something something. So we're actually really happy with that Z star of negative 1.28.
Wait, what's the one thing? Because I'm going to have to do
Okay, so in the order of the things, you have to put the percentage you want, and that's not the confidence level. It tends to be the opposite divided by 2, because 80 divided by 2. Well, 80%. You had 20 left over. 20 divided by 2. You knew the words. And then it's the 0 because we're assuming a 0 and a 1 for the standard deviation.
Wait, 0 standard deviation?
The mu and then the standard deviation. But seriously, every single time it's going to be 0, 1. Just figure out what percentage to type in. Sally, you have to remind me, are you an 83? Your calculator.
Oh, yeah, okay.
Okay, cool. Then it's going to do that. We have another calculator thing today. I just make sure we're on the same page. Louise, as always, I swear he's not listening, but I swear there's an appendix on the Inspire if you want to know how to Inspire button it, because it has the same buttons. Okay, cool. Okay. Yeah, I know. Okay, so. Absolutely. Does anyone else need a calculator? Because I'm hoarding them. I forgot all about the fact that I was hiding them from Albert T. Triggs, and then I was hiding them from you. And if you want to borrow it to do the next set of homework, I totally understand. Just let me know.
Did you already give us our next set?
I did on Monday, so you need to look in the Monday thingy. But yes, I pray it's in there, the leftovers. If not, I'll print you a new one. Okay. Whew. Okay, so we found the Z star, which is great. And again, it's easy to find Z star. You can either press inverse normal, or you can think things through like me. But again, we're reading this table in reverse. Instead of me telling you the outer ends and you find the percentage, you find the percentage we want and you tell the outer ends and give us the Z value, which is Z star.
So is that just another way to find it?
Yeah. So you can do this way. You could do just the calculator. Heck, I would probably, especially if it's a free response, do both to make sure they agree and I'm not completely insane. I had an insane moment earlier today when I was doing one of these problems until I realized what I did wrong. So, as is life. Okay. So again, what we did is we had our standard normal curve and we had these two tail ends. Like we knew this part. We want to be confident with our answers, that we're 80% confident. So we're really just considering those two tail ends of 10%. So we needed to put a number on it. So our Z star is between negative 1.28 and 1.28, hence the plus or minus with the Z star, because we've got the positive version for the positive tail end and the negative version for the negative tail end. Whew.
So you said it'll always be 0 and 1?
Always. Yeah, since it's always the normal curve, yes.
Wait, the areas what you're talking about, or no?
Yes, the area is always 1 under the standard normal curve. So it's always going to be a 0 and 1. She has to list it in her calculator. She doesn't have a cool...
So for me, it's always 0.1.
Yes. Well, for that... No.
For filling in the area.
For... We just did... She's asking about... The area is the tail end, so it would have to be, like, if this was not 80%, then this tail would not be a 10 and a 10, so no, it's not always 0.1. It is for this problem, but like if it was 90%, then it'd be 5 and 5, so 0.05. So it depends on the confidence level given. Okay, so got this fancy formula. We're going to plug it in and do things, which sounds great, except you can't do anything in stats class until, again, we keep going over and over these conditions, but you can't do anything in stats class until you prove the conditions. So let me just read through the paragraph. I feel like I'm in a rush and I need to slow her down. We can choose a simple random sample of size n from a large population that contains an unknown proportion of p successes. We don't know p, hence why we're using p hats in our formula. We're told some confidence interval, like 90%, 95%, 80%, told to some number. Again, the most popular is 95, but they'll give it to you if they want it to. Yes, so 0.025, right? Yes. Okay, so, but again, we can only use this formula if we've met certain conditions. So, we still have to have what Kenzie and I were calling a 10% condition, that the population has to be 10 times as large as the sample, which we're talking about, that was the independent part. We still have to have the normality part, which was the NP 1 minus P. We wrote it up at the top. You've still got to check that, except now it's probably dealing with a P hat because we don't know P. And then we still have to check random. It's got to say random somewhere in there. And the only new thing, the only new bit, which you might want to highlight on your notes. So I think you've got the random. I don't know what y'all are doing, but you're freaking me out. You've got, I swear you've got this. You've got the 10%. You've got the fact that it has to stay random. The only new part you might want to highlight that's different with confidence intervals is that the number of successes and failures are both at least 10. So if we flipped a coin and we've only had 5 heads, it's not good enough. We have to have at least 10. Okay.
So you need to have 10 successes and 10 failures.
Yes.
So 10 heads, 10 tails.
So that means at least 20 trials. So, I mean, even though we're not saying that that theorem applies of being greater than 30, sure could see why, because this is proportions not means, sure could see why we need a sample size fairly large in order to have 10 successes and 10 failures. Okay, so what really stinks is, again, you've got to check these things first before you do any math. Okay, and they tried to be cute and give it an acronym because people try to be cute when you're supposed to remember things. So, you know, when we were dealing with the normal curve and we're trying to do stuff with that, what did we do? What was the acronym? We cussed all the same time. So for this, with confidence intervals, if you're needing you an acronym, it is, it says state, plan, do, conclude. And the key to that is statistics problems, demand, consistency.
That's just more something to remember.
That's what I think too, but that was what the book
I
suggested.
say go
Duck's
with Space
better.
Duck. Let's go with Space Duck.
Space Duck.
I like Space Duck.
Yeah, I've finally done something
You just
worthwhile.
take out the vowels and you'll be good. Well,
Yeah.
okay.
I can die out, you know.
As long as you think through that there is crap I have to do before I get to do math, I don't care if you need to think of Space Duck. I just need Olivia to have some other junk on her paper before she attempts to do math. Because again, for last chapter and this chapter, the math part is not hard. The hard part is proving why you get to do the math. The math itself, mostly calculator stuff. No big deal. What we're trying to prove is why we get to do the math.
Space
Okay, so we're given a problem, and that leads back to 2 days ago. When we very first started, I don't know if you still have those notes out, we did a problem with this dude and his beads.
This dude and his beads.
Okay, we're not coming back to the dude and his beads, but this problem I need to reword before next year. This last sentence wasn't supposed to be told to us until later. It literally was supposed to be what Louise wanted all along, where it was 107 out of the total number of trials, which was, I just did this a few minutes ago. Where are my notes? 251. So you and I did this the other day, and instead of doing 107 out of 251, we did 107 out of 3,000 because we were told how many were in the sample. Like, we were told this total. It really was supposed to be this was our sample, and the 3,000 was supposed to be the total population. Now, is it our fault that the problem was worded that poorly? Heck no. It was worded a lot better when I ran into it in the textbook. The only reason I'm circumventing it and even bothering to come back to it, because everything we did was great, because we worked with what we had, and none of our, like, all our stuff is legit. The only reason I'm coming back to it today is because we're literally going to use 107 over 251 as our p-hat. So I just wanted you to know if you were like, but we just did this problem, Miss Compton. We didn't use 251, we used 3,000. I know, My bad. It was worded weird. Why wouldn't we go with the 3,000? They weren't supposed to tell us the 3,000. It was supposed to come later on. I digress. Okay, so our problem today. They want us to, it says Mr. Vignoli's class took a simple random sample of beads from the container and got 107 red beads, 144 white beads. Recall yesterday's example. Calculate and determine a 90% confidence interval for P. Okay, so we've got to do part A. Before we can even do any of the math, we're going to have to space duck or whatever acronym you're wanting to use.
Yay! I forgot what it's Statistic.
I think a RIN, because I know I need random, independent, normal. But if you want to space duck it, as long as you're checking some conditions, I'm good. So we need to know if everything's normal. We need to know if everything's independent. And was our sample random? Now, hopefully, it tells you random. If we look back at the problem when it was worded fully from the day before, it was given then, so we're going to assume given now. For the independent and the normal, again, we still want to check this 10% thing, and we still have to check the NP hat greater than or equal to 10. So, the 10% rule. So, we have a total of 271. For our sample, it says 271 because 107 and 144 added together. 251. Why can I not add today? Okay, so our sample is 251. 251 times 0.10 is 2510. Isn't that bigger than the 3,000? So we're technically good on this one because we were told that the population was 3,000 beads. And so our sample is fine. Oh, less than. Bless you. God. Math was coming out fun times. Bless you.
Wait, 251 times 0.1.
251. I meant to do it the opposite way, didn't I?
Did we do it opposite way of 10 and not the decimal?
Yeah. We need to multiply times 10 because we're checking that it's at least 10% of the Lord Jesus help us. Why am I mathing? Out the window mathing. But again, we weren't even supposed to have to recheck these again today. We were supposed to have them done from 2 days ago, but you and I misread the problem because it was worded stupid. And then the NP hat, it's going to be greater than or equal to 10. So we have 251. Our success was 107 out of that 251. Is that greater than or equal to 10? Yes. And then our N times 1 minus P hat, 251 times the 144, our failures, over 251. Is that greater than or equal to 10? And yes, it is. So we're good to go. Yeah. But literally, if you've not shown that you've checked some conditions, it's not okay for you to do math. Now, if the conditions fail for some reason, should you keep going and maybe say the conditions have failed, but if whatever, miracles happen, blah, yes. But you cannot actually do the math until you've done this space duck or whatever acronym you wanted to say. So you and I've even failed on the space duck. We've identified and checked the conditions. We did not consider the S in space duck. If you look up higher, it said state. What parameter do you want to estimate and at what confidence level? I just assumed we can handle that, but maybe I need to think things through. what is P in our problem? Clearly our confidence level is 90%.
Yeah.
What is P? What are we wanting to know? What are we wanting to estimate?
This is confidence level.
Okay, so confidence level is just the percentage. When we're about to try to make an interval after that, like 90% confident, blah, 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 here are my numbers. It's between like 0.38 and 0.46. When we add a little interval in, it's called a confidence interval. That's literally the difference. Is there an interval in it? It's an interval. If there's just a number percentage, it's called a confidence level. It's dumb. I know. Yes, that formula that we've circled, we're about to use it and figure out those numbers. Okay, so we've checked conditions, so we get to do math now. So the formula says P hat plus or minus Z star, and then the square root of P hat, 1 minus P hat over N. Literally going to start plugging in, studying some stuff now. Our P hat was 107 out of the 251 because 107 out of the 251 times we got red beads. I typed that in my calculator, I got 0.426. So everywhere I see a P hat, I'm going to put 0.426. So that part was easy. The N we're given, it's our total sample, which we know is 251. So I'm going to put N as 251. The only thing I have left to consider is my Z star. And we said 90% confidence level. So I can either get a different pen color, that's for sure. I can either use my table A with my standard normal curve with the Z-scores and figure out, okay, we're 90% here, then the two tails are 5%, so I need to look at my table and get as close to 0.05 as possible, and I can do that and I'll get the right answer, or I can press the inverse norm and you'll still get the correct answer for the Z star. Yeah, so I would be looking at 0.05. I believe that is correct. 645 if we're being really, really exact. So again, I can either look at my table. So we said as close to 5 as possible. So that's a little too high, a little too high, a little too high, a little too high. Finally got there. So you're like, it's in between these two. So either I'm going to say negative 1.65, or maybe I'll say negative 1.645, because that's the average of the two. And again, I get this fluidity of the Z-table is annoying, because, you know, this is static. We're not getting the exact answer. If you're wanting the exact Z-star, you're still going to get all your points in life if you put negative 1.64 or negative 1.65. But if you're one of those people, we know who you are. It's okay if you second bars, inverse normal, the area is 0.05, and we'll still get negative 1.64 or 645. Because technically that 8 rounds up that 4 to a 5, so negative 1.645. Yada, yada, yada. So I'm going to put negative 1.645 for those who are in, or 1.645 because it's plus or minus. But again, if you did just 1.64 or just 1.65, they're probably going to give you like all your points. You still have everything correct. As long as your words sound good, you know what you're doing. Okay, this is where the math skills in life come into hand. Because literally, I don't know you that well, so I'm going to go through this. But hopefully you know how to do that. Okay, I'm going to show you how I would do it. You can be your own person. I don't like to write down intermediate steps because I might make rounding error. And then they can, what if you miscalculate something? They can count off if you've made a mistake in your work. So I literally like to show as minimal work as possible. I do most of it in my calculator and store most of it in my calculator. So I'm going to type in everything under the square root into my calculator first, deal with it, then multiply by the 1.645, and then deal with that 0.426. That would be the best way to handle things. Now, if you want to calculate this, write that down. Then I'm not saying you can't. I'm just saying be very careful, because if you make an intermediate arithmetic mistake, they're going to count off for that, which is sad because you knew what you were doing. Okay, so I am going to start off with the 1.426. So 1 minus 0.426. I got this number. Then I'm going to multiply times 0.426. I now know that numerator. Everyone good here? So I know that numerator. I divide by 251. I now know that entire fraction. I need to take the square root of that entire fraction. So second square root, second answer, which is normally down near the bottom. And now I know this entire green thing, radical and all, is that decimal. I'm going to take that decimal times 1.645. Did I do anything too fast? Is everyone good? Okay, so times 1.645. Now, maybe I want to write this part down. Or maybe you like the store button. I like the store button. So I know I'm going to need this part twice, because I've got to do 0.426 plus that and 0.426 minus that. So I'm going to store this bad boy in my calculator. You can store by pressing STO, and then you pick what letter it sticks as. So I'm going to store it as X. I can clear that out and change my mind later on in life, but now I have it saved. So now from here, I'm going to do 0.426 plus X, because again, I've stored that as X. So I know my upper limit is 0.477. But I've also got to do 0.426 minus X to get that lower limit of 0.375. So again, I stored this bad boy as X. This whole thing is X. So I did 0.426 plus X to get the upper one, 0.426 minus X to get this lower one. And now I have this range of values. Yes, dear.
Is not negative 1.645 for the Z-star?
Again, it's for both. That's why it's got the plus or minus. It's, yes, you and I keep doing it, and yes, this one's negative 1.645, but the upper tail would be 1.645. That's why they're doing the plus or minus for the positive end of the tail and the negative end of the tail.
I know that, but when you add it, doesn't it become like...
Yeah, like you said, it was negative 1.645, and then plus the plus or minus. So when we put that number in there, it was a negative.
It's still the same two numbers.
Yeah, but it switches.
It just switches the plus or minus to a minus or plus, but it's
It's still the same two numbers.
yeah, it's
But
still
it
the
would
same.
still switch the upper and lower.
Yeah, no, because
But
all
you keep the lower number where the lower one is and the higher number.
yeah, it's no, you're trying no, don't make it like that deep.
Okay,
Don't make it like that deep. Literally, no,
I'm sorry.
don't make it like that deep. Literally, just forget the sign then if that's gonna bother you. I know it would make it a minus. I don't care. Even if it made it a minus plus, it's still gonna be the same two numbers. Even if I change this plus or minus to a minus plus to make you happy, it's still gonna be the same two numbers. Okay,
It's the same because it's negative.
I understand, but
It's still the same two numbers.
But then it would be plus minus, which would make the top a minus, minus minus, which makes the bottom a plus. So literally, you just want me to change my plus or minus to a minus to this. But is that even worth it? It's still going to give me the same two things. So let it go like Elsa. No, I just like referencing it. Okay, so we did all this math. Woohoo, yay for us. We now have a range, so we get to use our words because it said calculate and interpret. So we are 90% confident that the interval No, I am. I don't know why I said we. I guess the class. I am 90% confident that the interval 0.375, comma 0.477. Or if you want to put in English 0.375 to 0.477, doesn't matter. Captures the actual running out of room English fun times. The actual proportion of, and then what were we wanting? Again, we had to state the parameter for a reason. We were wanting specifically what were we trying to figure out? 90% confident about what? About the what kind of specifically? Yeah, so proportion of red beads. And then back to we could be really smart butts and super reference the STEM. So not just red beads in the world, specifically in this dude's class. So in Mr. Vignolini's class. Vignolini's containers. It could be that kind of a jerk. Up to you. Okay, so literally the math part was easy. The conditions weren't that bad. And then we just put words. Take the percentage they gave you, confident that whatever it is we were looking for, which happened to be proportion of red beads in this dude's containers, is between here and here. Part B is super easy. We can do it, and then we'll talk about the next calculator button, and that's where I'll stop rambling. Part B. Mr. Vignoli claims that exactly half the beads are red. Comment on this claim. Look at your range.
No.
And then he said 50%.
Exactly.
So, no. No. So, no. So, since 0.5 is not in our interval, I don't believe him. I doubt Mr. Vignolini. So, say something smart about since 0.5 not in interval 0.375, comma 0.477, and then something about why you don't believe this dude. Yeah, and I would say, I mean, and of course you could say I was 90%, you could be a complete smart jerk with this second part. You could say I was 90% confident my answer was between here and here, and he gave a value that's not in that range, therefore he's crazy. And then all of this makes Hunter sad because he's like, why on earth do I have to actually do math in math class? Why are there not calculator buttons for me to just press? And there are.
They just don't know them
Yes. Miss Compton has yet to tell you all the secrets of life yet.
I made a space step.
I like it. Okay, I'm going to stop recording and I'm just going to say words. It's okay if you pack up.